Well, the question here says in the figure, points K, A, and F lie in the same horizontal plane, and TA represents a vertical tower, and then the angle ATK equal to X, and the angle KAF equal to 90 degrees plus X, where X is in between 0 degrees and 30 degrees, and TK equal to 2 units. Now, question 6.1.1 says express AK in terms of X. So I'm right here 6.1.1. So that says express AK in terms of X. This is what we're looking for. All right. I'm going to paste the same to do the same shape over here. We can notice that okay, the line that we're looking for, we need to express this AK in terms of X. I prefer to look at this triangle. You see in this triangle, T, K, okay, this triangle, as you can see there, A is over here, and then K is there, and then, okay, because this triangle makes a 90-degree angle. Why am I saying that? Because we do know by definition that sine of the angle is equal to opposite over hypotenuse, okay? And then the angle that we're looking for is X. That's why we say the question says we need to express X in terms of, express AK in terms of X. So opposite of the angle X is this side AK, okay? This side is opposite to X. And then the hypotenuse is the longer side, that one. Now we can work out, we can say sine of X equal to opposite, which is AK, over hypotenuse, which is 2, given by 2 units, okay? Then we can express here, we know that sine of X is like sine of X over 1, and then we can apply the cross multiplication property. So this would be AK 1 times K, 1 times AK makes AK equal to sin X times 2. Careful here, don't write sin to X. It's not the same thing, okay? We don't do that. Instead, we're going to say we're always going to put the constants in front. So this will be 2 sin X. That's the value of AK. Thank you. We can now do question 6.1.2. Let's say calculate the numerical value of KF. All right. I'll first move my screen over here, my board over here, and then split like that, and then write 6.1.2. Okay. We are looking for KF here, the numerical value of KF. Now, let me paste the graph there again. Now, we are looking for KF is over here. So we have another triangle here. As you can see, this angle over here is not a 90-degree angle. Obviously, let's say 90 minus X, so it's not 90-degree angle. So we cannot here use, okay, we cannot use this formula. We cannot say, we cannot use this sine formula. Sine of the angle will be in order to find K. Okay, we cannot use, say, opposite over hypotenuse. We cannot use this one because we don't have a 90-degree angle. But we can use another formula called the sine, usually called the sine rule. Okay, okay, sometimes I get this question like when to use the sine rule, when to use the cos rule. Okay, or maybe why not the cos rule here? Okay, cos rule can be applied. You can use the cos rule if all the sides are given, or you have a SAS side angle side. Okay. Like we know this angle, we know this side, then we can use the cos rule. Or we have all the sides given, then we can use equals to. But otherwise, we use the sign rule, like in this case. Okay, sign rule says this. Sine of A over A must be equal to sine of B over B, and this must be equal to sine of C over C. Okay, and now it depends now how we labeled our value. So if A is here, so this must be A, then this side is A, the side AK is A. Because this is K, uppercase K, so the sides must be the lowercase k, and then this is F, so this will be lowercase f. So that's how we label those sides. Now I need KF. What I can do, the same formula can be written like this. It can also be written like this, or A over sine A equal to B over sine B, or equal to C, lowercase c, equal to sine uppercase C. This C, I wanted it to be uppercase, but my uppercase C looks like my lowercase c, so I'm going to make it a little bit bigger. Now we can use this or that, the first or the second. It doesn't matter which one we use. So if I go for the first one, for instance, I'm gonna write, I'm looking for KF. KF is like A here. I'm gonna say sine of the angle. The angle is of here, where opposite the side KF is 90 degrees plus X. Okay. Let me take it off. Yes, it is 90 degrees plus X. So put it back there. That will be 90 degrees plus X all over KF. Okay. Then this must be equal to AK here, this side AK. I want to say, no, let's take sine of 2x. Sine of 2x. So I'm going to say sine of 2x over the opposite is the sine. You have angle 2x given there. The opposite is F. Our F is AK, so over AK. Okay. Then we can reduce this. Okay. Sine of 90 degrees plus X is equivalent to cos of 90 degrees. So this will be cos of X over KF. Okay. And then sine of 2x can be written as, according to this property, sine of the double angle property is equal to 2 sine theta times cos theta. So I use this property over here. This will be then 2 sine x cos x over AK. In the previous question, we work out AK, it was 2 sine x. So I can substitute the value of KA. This is 2 sine x. Now we can simplify over here the fraction. We can cross the 2 with the 2, and then the sine x and the sine x. Now, which means that this will be cos x over KF equal to cos x. Now cos x is like cos x over 1. We can cross match. Okay, that's from here we can see in the both sides of equality we have cos there, we have cos there, meaning KF equal to 1. We can do that. Yes, we can. You can cross cos x if you have an equal sign in between the term like this. You can cross this cos and that cos, and then say therefore KF equal 1. Or you can also apply the cross multiplication property. I promise you, you're going to get the same answer. Look, check this out. Assuming that I didn't cross, assuming it was just cos x over kf equal to cos x over 1. If I cross multiply, I will have I cross multiply, I do kf with cos x and then cos x with 1. So this would be kf cos x equal to cos x times 1, which is as cos x. And now if I need to find kf, I must divide by cos x both sides, and then this make kf equal to 1, because we can simplify this and that, and then we left with not 0 but 1. Okay. We can also use expression number 2. Number 2 here, the formula number 2 here, it's going to lead us to the same answer. You can check it out. Let's say I'm going to split it here. Let's say I use this formula here, A over sin A, and then equal to B over sin B, equal to C over sin C. So now I'm going to paste the same shape here. This is what we have. We are in this triangle here in blue. We can say we can use the formula A over sin A equal to B over sin B, I mean, and then C over sin C. Now A is the side opposite sin A. If my sin A is 90 degrees, 90 plus x degrees, so A will be kf. So kf will be over sine of 90 degrees plus x. Okay, and then if my B, the angle is B2x, then the opposite side will be that. So I'm gonna write AK over sine of 2x. Now kf, that makes kf over cos of x, because we can change sine 90 degrees plus x into cos x. And then AK, we find the previous question was 2 sine x over 2 sine x, sine of 2x, according to identity is 2 sine x times cos x. Then we can simplify this 2 and 2, sine x and sine x. And then we have left with cos kf over cos x equal to 1 over cos x. Again, as in the previous, this implies that kf equals to 1, because the denominator here are common. You can also cross multiply, you're going to get the same answer. Thank you.